All right, indirect proofs and inequalities in one triangle. First, an indirect proof, also known as a proof by contradiction. What we do is we prove a statement true by actually contradicting what the opposite of that says. So our first step is to assume that the opposite is true. We reason logically until we reach a contradiction, which would be our second step, so an impossibility, and then step 3 is to actually summarize that the desired conclusion, the original statement that we wanted to prove, must be true because its opposite is false. Okay, I know it sounds a bit confusing and a little weird, and these proofs are, but we'll go ahead and try one here. And actually, let's get a real-life example first, or maybe an everyday example. You have accused me of taking your lunch out of a shared refrigerator at work on April 9th. So let's say someone accuses you of that. Let's temporarily assume that I did take your lunch. Then I would have had to have been at work on April 9th. However, I have an airline and hotel. I have airline and hotel receipts showing that I left for an out-of-state trip on April 6th and returned on April 11th. Therefore, I was not the person who took your lunch out of the refrigerator, obviously because they weren't there on April 9th. So by first assuming that I did take your lunch, I can disprove that I took your lunch by saying I was out of town and proving that I was out of town, meaning I've then proven that I did not take your lunch. Okay? Once again, kind of weird. We'll try to apply it some geometry here. So write an indirect proof that in a given triangle there can be at most one obtuse angle. So I'm going to break this into our steps again, these steps we had on the very front slide here. Okay? So step 1 is to assume that the opposite is true. So given triangle ABC, prove that we can have at most one obtuse angle. So let's say step 1, let's assume triangle ABC has 2 obtuse angles. All right, and I do some abbreviating as we go. Okay, so step 2, oops, apologies there. Step 2, by definition, we know by definition of an obtuse angle, and it would be helpful if you pause this and kind of think through it before. Remember, we're trying to, in step 2, we're trying to contradict step 1. We're trying to disprove step 1 by reasoning logically that you can't have 2 obtuse angles. And when I say reason logically, we're talking mathematically as well. Okay? You can't just say, well, there can only be one obtuse angle. Okay? You have to mathematically state why that is. Okay? By definition of an obtuse angle, we'll abbreviate that, the measure of angle A, of our triangle, angle A, would be greater than 90 degrees. And in this case, the measure of angle B would also be greater than 90 degrees. Now I could have picked any of the 3 angles, or two of the 3 angles to be greater than 90. I just chose A and B. Okay, and we know that by the triangle angle, actually write that out, triangle angle sum theorem, the measure of angle A plus the measure of angle B plus the measure of angle C of any triangle would have to equal 180 degrees. Okay, let's do some substitution here. Substituting the smallest whole number values for angle A and angle B, which would be, the smallest whole number values would be 91 degrees if they're both obtuse. We would then have 91 plus 91, or A plus B, plus the measure of angle C has to equal 180 degrees. Now some of you might see the problem. Well, if we do the math here, that means mathematically we would have on this side of the equation 182 plus the measure of angle C equals 180. We subtract both 182 from both sides, we get the measure of angle C is equal to -2 degrees. Okay. A triangle cannot have a negative angle measure. So you've now disproven step 1, which was assuming the triangle has two obtuse angles. Step 3 is our summary. The assumption that triangle ABC has two obtuse angles must be false. That means this proves that triangle ABC can have at most one obtuse angle. And remember, you always want to end with what you're trying to prove there. Okay. All right, there we got it. Now I will say, like, I just kind of flew through that in class. Like, we would spend tons of time talking about this stuff. Okay, and probably lots of groans, like, "Oh my gosh, we got to write all that just to show that." We know already know that. Yeah, we're trying to go through a way of thinking with indirect proofs. Okay, so it's almost like those arguments you may have with friends or maybe parents, and where you kind of go back and forth, round and round, and you try to disprove by your logical thinking in some way. Okay. All right. Let's look at another one. This one I will admit right at first is tough. Okay. Write an indirect proof that an odd number is not divisible by 8. Well, this will be the last one we do. Okay. It's important to note a few things. First, we're going to go through the steps again. Okay. Step 1, and step 1 is always one you should. A lot of times you'll be asked just to identify step 1. So identify the opposite. So let's assume, okay, an odd number is divisible by 8. Okay. So step 2. Step 2. We need to figure out a mathematical way to represent an odd number. So let's let the odd number be represented by, now just so you're clear, like it's fairly easy to represent an even number, right? So I'd ask, what's an even number? And you count off 2, 4, 6, 8. And you're like, yeah, it's any number. Oops. All right, come on now. Well, maybe I'll stay on the... All right, let's see if I can actually get to the page and stay on the page I want. Okay, an even number is 2, 4, 6, 8, so anything that is multiplied by 2. So if I say x, well, multiply x. So if x is 1, I double it, I get 2. If x is 2 and I double it, I get 4. If x is 3 and I double it, I get 6. So any number multiplied by 2 is an even number. Okay? Well, then an odd number, well, think about an even number. If you're at an even number, so let's say we're at an even number, and I want to get to an odd number, what could I do? Well, I could add or subtract 1. So if I'm at 2 and I want to get to the next odd, I just add 1. I'm at 3. If I'm at 4 and I want to get to the next odd, I just add 1. If I'm at 6 and I want to get to the next odd, I add 1, right? I get to 7. So odd numbers are always 2 times x, an even number, plus 1. Okay? So let's let the odd number be represented by 2x plus 1. Okay? Where, let's define x. X is a positive integer. Okay. All right, so now it's also important if we're saying an odd number, we've kind of defined that, divisible by 8. Well, what's a number that's divisible by 8? We kind of did that with 2. A number that's divisible by 2 is 2x. So really, a number that's divisible by 8 would be y. So, so what we know now is if a number is divisible by 8, 8y, y would give us an even number, or an integer, and if a number is odd, then x would give us a positive integer. Okay, so let me kind of expand on that just really quick, and I'll expand on it right down here. Okay, so 2x plus 1, that's an odd number. Okay, if 2x plus 1 equals, say, 7, then we solve that, we subtract 1, divide by 2, x would have to be 3. Okay, it's an odd number. Okay, if 2x plus 1 equaled, say, 9, we subtract 1, divide by 2, we get 4. X is 4. All right, it goes in 4 times. That's how many times x goes into, or how many times we multiply an integer by 2 and add 1. Okay, so we get a positive integer when we solve there. Okay, these are all odd numbers, right? When we set them equal to odd numbers, we actually get whole values. Now, what happens if I set 2x plus 1 equal to, say, an even number? Okay, well, I subtract 1, right? I get 2x equals 9, and I divide by 2, I get x equals 4.5. Okay, well that's not a positive integer, so that doesn't work out. So I'd have to get a positive integer out. I get a decimal value. Okay, well, let's go ahead and divisible by 8. Well, let's say 8y will give me a number divisible by 8. Well, is 1. There's 8. Well, that's 1. And 8y, let's say 24. Well, divide by 8, we get y is 3. Let's say we use, like, say, I don't know, 30. When we divide by 8, we get y equals 38. That is not a positive integer, so it doesn't work out. So what I want is I want an odd number that is divisible by 8, right? That's what we're assuming, an odd number that is divisible by 8. So what I want is I want 2x plus 1, an odd number, to be divisible by 8, to equal 8y. Okay? If that's the case, you know what, I better define y here, where y is a positive integer. Okay? So if that's the case, I should be able to solve that, right? I should be able to solve for y, or solve for x, either one, and get a whole number value out. So if I get y by itself on one side or x by itself on one side, I should be able to have, I should have a whole number value. Okay? So let's solve. 2x plus 1 equals 8y. We'll do the math. You know, I could have just done that right there. Let's just do it from right here. Yeah, get y by itself. That's the easiest one. Divide both sides by 8. So I get 2 over 8x plus 1 over 8 equals y. Okay, well, look at that. That doesn't look like it's going to give me a whole number. Okay, the only way I could get a whole number is if x was a fraction. And we know x can't be, or not a fraction, but a non-integer, right? It would have to be what a lot of you just consider a fraction, okay? So if we look at it and say, well, that's like having 1/4 x plus 1/8. That means in order for me to get a value out that's going to be a whole number, this is going to have to be a fractional, a portion of something, a portion of a number, right? And we know x can't be a portion of a number if it's an odd number. It has to always come out to be a whole number. Therefore, what we've done there is when solving for x, or excuse me, for y, we get y equals 1/4 x plus 1/8, which is not an integer. Okay, so step three, we summarize it, the assumption that an odd number is divisible by eight is false. So an odd number is not divisible by 8. All right, a little number theory there, actually a lot of number theory there, but hopefully that'll help out with some of those tougher problems. Okay, let's kind of switch it up here. Let's deal with inequalities in a triangle, okay? So use the triangle to complete the following statements, and I'd hope that you'd pause this and look at the triangle first, but the blank side is opposite the blank angle. So when I'm looking at this, I start looking, oh, here's a small angle, here's a medium angle, here's a large angle. Here's a small side, here's a medium side, here's a long side. Well, notice that the longest side is opposite the largest angle. And that's what we're looking for there. Once again, in class, we'd spend a lot more time on that, but the longest side is opposite the largest angle, which also means the shortest side is opposite the smallest angle. Okay, and that leads us to the triangle longer side inequality. It says if one side of a triangle is longer than another side of the triangle, then the angle opposite the longer side is larger than the angle opposite the shortest side. Okay, the longest side is always opposite the largest angle. In other words, it doesn't touch the largest angle. And the smallest side is always opposite the smallest angle, which means it doesn't touch the smallest angle. Okay, so if one angle of a triangle is larger than another angle of a triangle, then the side opposite the greater angle is longer. Than the side opposite the smallest angle. Okay, so that's triangle larger angle. All right. Let's go ahead and apply this a bit. List the angles of triangle ABC in order from smallest to largest. So don't get mixed up and go the opposite way and go largest to smallest. So the first thing, if I know the angles are tied to the sides and I want to go smallest to largest, I'm going to list the smallest side first, so AB. And then I'm going to list the medium side, which is BC. And then I'm going to list the longest, which is AC. Okay? So now I want the angles. Well, from smallest to largest. Well, you could look. You could go, okay, AB is opposite angle C. And you could go, well, BC is opposite of angle A. And you can go AC, right here, is opposite angle B. So now I've got it. There's smallest to largest. The other thing you could do is just look. Which letter's missing in this side? C. Which letter's missing in this side? A. Which letter's missing in this side? B. It's a quicker way to do it. You can do the same thing with sides, right? If you're going list the sides of triangle ABC from shortest to longest, well, look at your angles. The shortest side is always opposite the smallest angle. Okay. Smallest is B, final one is A. Okay, well, I just kind of gave you a quick shortcut. The letters that aren't contained in the angle are the side that's opposite, so that's AB. AC and BC. There you got it. You can double check it, obviously you should. Okay, but it's good. All right. Let's try about the triangle inequality theorem here. All right. So notice this little picture off to the right here. Well, these sides will not make a triangle. Like if I try to connect the 1 and the 2, these are the lengths. They just don't reach. In fact, if I made this one 2, it would just make it so that this thing kind of fell flat on its face right here, like the 2 would swing down, and it'd just lie right on this line. So really it means the sum of the lengths of any two sides of a triangle have to be greater than the length of the third side. Okay? So using that, we know if I have this triangle right here, AB plus BC, so AB plus BC has to be greater than AC. And AC plus BC has to be bigger than AB. So any two sides have to be bigger than the third. So AB plus AC has to be bigger than BC. Has to be greater than BC. Okay, that's a triangle inequality. It seems pretty obvious, but sometimes we just don't think about it. So let's apply this. I think this will be the last thing we do here. The triangle has one side length of 16 and another side length of 11. Describe the possible lengths of the third side. So you have two scenarios, really. You could say, well, the third side, we're going to call the third side X. Okay. So we could say the third side is a small value. Of X. In other words, it's not the longest side. That's one scenario. The other scenario is a large value of X, which means it is the longest side. Okay? So if we label these pictures here, well, if it's a small value, that means the longest side is either 16 or 11. And in this case, obviously, it would have to be 16, which makes the other one 11. Meaning the two shorter sides, X plus 11, than the longest side. Which means X would have to be bigger than, well, subtract 11 over, you get 5. X has to be greater than 5. And if X is the longest side, that makes 16 and 11, the other two, which means the second longest is 16, and then we have 11. Which in that case, the two shorter sides, 16 and 11, have to be bigger than the third side, or the longest, which is X. Which means 27 is greater than X, or if we switch and put X over here, it's X has to be smaller than 27. Which means in this scenario, X has to lie between 5 and 27. Has to be greater than 5, but less than 27. Those are our possible lengths. Can't be 5 or 27. If it's 27 here, it doesn't make a triangle. And if it's 5 here, it doesn't make a triangle. Remember, it just kind of falls flat and lies on the other line. Okay? So, those are our scenarios. I think that's all I got. Yep. All right. Good luck.